We're rolling.
Okay. Okay, so let's. This is your real. This is your imaginary. So, what did you learn when you had something like this? Let's say z equals a plus bi. How do I graph a plus bi? What's the general way of doing that? Yeah. What is it? Okay. This is my real number. What's your imaginary number? The coefficient on I. Okay, so this is your A, that's your B, and that's where that would be, okay? Excellent. Good job. Way to go.
What's our code for group class?
I'll give that to you. I'm glad you hooked it all up when I gave you the three.
Well, I had none of that. I thought it was on it, but I don't know group class.
Everybody's going to Google Class. They're going to eventually make everybody go to it. Because you can't, your Google Drive is not hooked to your dead phone.
Yeah.
And we want to have Google Drive hooked to everything. And the classroom gets better. They're making it better. All right, so this was the generic part of this. If I said z sub 1 equals 2 minus I, where would I graph that? Those of you, everybody should have their hand up. Everybody should know how to do this. Based on what I just said there, where am I going to graph it? Abby, you do the first one.
Over 2 downward.
Yep, I'm going to go to the right 2 and down 1. Because the coefficient's -1. Great. What about z2 being 2 plus I? Where would I graph that? 2 plus I.
Over 2 up 1.
Over 2 up 1. Good. So z sub 1, z sub 2. Okay. Well, how do I calculate z1 times z2? How do I calculate it? What would I do? 2 minus I times 2 plus I. And we've already done stuff like this many, many times. What do I get?
4. 2i.
What is I?
1. It's the square root.
Square root of -1. So what's I squared?
It's 1.
-1. Minus the -1 is? This is still 5 plus 0i. Just because I don't have the 0i there doesn't mean it's not there. Okay, so at 5, that's where z1 times z2 is. That was number 19. You didn't have to do that one. That was part of 19. Okay, so you learned how to use rectangular coordinates, the xy graph. You just learned how to do polar coordinates, how to plot polar coordinates. You learned how to convert from rectangular to polar. You learned how to convert from polar to rectangular. You learned how to convert rectangular equations to polar equations. You learned how to convert polar equations back to rectangular equations. What are the 4 things you're supposed to know that you learned on your reference sheet? Good. Y equals? What else? Good.
X squared plus y squared equals r squared.
Excellent, 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 excellent. Good job. That's pretty cool. This is a complex form. A plus bi is complex form. So we're going to go from complex to polar. Okay. The polar form is this. That's the polar form. And they got that from the unit circle. Yeah.
Do you want us to write that down on our sheets?
Yeah, that should be on your sheet. Polar form. So we're going to convert the complex form to polar. That's all we're doing today. This is the second half of what you learned. Okay, so I'm going to show you this. That's R, this is A, and this is B from your complex graphing. This is I, this is your real. So just kind of, it doesn't really matter because even in polar form, polar coordinates, it's this way. How do I find R? If I ask you what R is, what is it you use to find R? It's a right triangle. They use it for right triangles. Pythagorean theorem. So R squared equals A squared plus B squared. So what's R equal? Come on, say it. How did I get R from R squared? Square root. Thank you. Pythagorean theorem, guys. Come on. What's A and B? A and B are the real and the coefficient on the imaginary. That's all that is. Okay? That's how I'm going to find R when I transfer the complex form to the polar form. That's step 1. Find R. Step 2, I got to fill in what theta is. Not the value of cosine of theta. I just need to know what theta is, the degree. How do I find theta? Tangent of theta. You're going to be given the x value and the y value, aren't you? Well, if I have that, I can find theta, just like what we did the other day. Same thing. That's step 2, using the tangent of theta to figure this out. Now, let's actually do a couple problems. It's very simple, but you gotta, it's not as simple as the graphing part. A little more difficult than that. Let's do this one. This is number 30. 1 plus radical 3i. So you're going to convert that. First of all, I don't even know if it tells you to graph. I'm going to graph it just because I want to know where it's at. Where's it at? Somebody graph it for me. Tell me what to do. Somebody raise your hand and tell me what to do. I know you know how to do it. Abby's the only one who can graph. Over 1 and up radical 3, which is 1.7. So about right there. So here's where I'm at. So this is your radical 3 and this is 1. I need to know theta. First of all, what's step 1? What did I tell you step 1 was? Find R. So how do I do that?
1 squared, the square root of 1 squared plus square root of 3 squared.
What is that? Everybody do this calculation. Raise your hand when you have the answer. Got it? No. What's 1 squared? What's the square of a square root? What's this? Square root of 3 times the square root of 3. Square root of 9, which is 3. Anytime you take the square of a square root, it's just a number. So 1 plus 3 is?
4.
Square root of 4? 2. Good. Excellent. R is 2. So we have the first part of what we're doing here. The new form is 2 times the cosine of theta plus I times the sine of theta. I don't know what theta is yet, but we're about to find out. What's step 2? Find theta by using what? Tangent of theta equals y over x, b over a, square root of 3 over 1. Now, pay attention. If you didn't know what that was, you could take the arc tangent of it. Right? When you don't know, if you can't figure it out because it's not on your unit circle, you have to use the arc tangent. This is on your unit circle. These are the 3 values in your unit circle, right? Here's how you do this. If you see the square root of 3, write square root of 3 over 2. If you see 1, you write 1/2. If you see radical 2, you write radical 2 over 2. Aren't these two equal? Yes or no? Yes, they are. That's how you do this. Plug those in. Whenever you see radical 3, you put radical 3 over 2. Whenever you see 1, you put 1 over 2. Because those cancel out, leaving what you have here. Now you know where you're at on the unit circle. This is your long leg. That's your short leg. Y is the long leg. X is the short leg. Where am I at? What is it? 60 degrees, which is, in terms of pi? Pi over 3. This is how you do this. Anytime you're dealing with tangent, this is the process you need to be thinking of. Now, if it's not on the unit circle, then you're going to have to use arctangent to get the degrees. Now, I want to show you that this works. Work it backwards. This is the answer. So, what's the x value at pi over 3? What's 2 times 1/2? 1. What's the y value? Radical 3 over 2 times 2 is radical 3 times the I. They are equal. That's what a conversion is. It just looks different. They're equal. They're the exact same thing. Ready to do another one? You can do this on your own. All your problems today are just like this. Step 1 and step 2. Let's do number 42. I've done this one. Radical 3 plus, oops, that's a plus. Plus I. Begin. Step 1. Find R. R is not always going to be the same, so don't let that fool you. Let's see what you got for R. Keep going. Try to find theta. Slow down. Don't too fast. Please.
I'm lost now.
What did you do R yet?
Yeah.
And what did I say to do with the 1 and the radical 3? What did I say over there? Replace them. Did you get R?
No.
How do I find R? A squared plus B squared.
Yep.
What's A?
2.
Abby? What's A?
3
Square root of 3. What's B?
Sorry, I was being distracted.
What's the square root of 3?
3.
Abby? It's 1 squared.
1.
3 plus 1. Square root of 4. That's step 1.
It's the same thing.
Just happens to be the same.
Yeah. You said it wouldn't always be the same.
Tangent theta is y over x, b over a. What did I say to do? I said to replace those values with your one of the 3 fractions. So your y value is the short leg now. The x value is the long leg. So what is theta? What? 30 degrees, which is 5 over 6. So here we have 2 cosine of pi over 6 plus I sine of pi over 6. And that would be the conversion. That's the polar form. Who got that right? Okay, let's do another one. Last one. Last problem. Do exactly what I tell you to do. 36. Negative 3 minus 3 radical 3I. Find R first, please. Remember, you need to know where you're at. You will all miss this problem because you're just kind of going through the motions. So be aware of where this is at. Just find R first. Well, 3 times radical 3 is about 5.1. That's the right idea, though. So you're in the third quadrant, right? That's the important part. Good guess, but you need to show why.
Thank you.
Anybody get this far yet? Alright. What's theta?
It's radical 3 over 1, and then you do the radical 3 over 2 over 1/2, and then,
How'd you get radical 3 over 1?
because the negative 3's cancel.
Okay? Is that what you're saying?
Mm-hmm.
So you did this, right?
Mm-hmm.
And so what does that tell you?
And then it's a 60 degree, which is pi over 3, yeah.
So you're saying theta is pi over 3. And I'll say you just missed the problem. You did everything correctly. Everything. Except these are negatives. I'm here. It is a 60-degree reference angle. That's what you figured out. Just like that. What is this?
Yeah.
It's 4 pi over 3.
4 pi over 3.
Thanks. Appreciate that.
So you gotta be, the whole point of me giving you this is to say, yeah, okay, you went through the whole motion, you did everything right, negative over negative is positive, but it's pi over 3. You gotta be aware of where you're at, and that these are both negatives, so I'm in the third quadrant. Just looking at these values, you should know where you're at. You don't have to graph each one. So when you do this, this is gonna give you your reference angle, okay? Or, I mean, it may give you exactly where you're at. We haven't done all the problems, so. Just be aware, by starting the problem, where am I? And you might be able to tell exactly what your theta is. You need to show me this, okay? But hopefully you get to the point where you're like, okay, that's gonna be a 30-degree reference angle. I'm in the fourth quadrant. That's 11 pi over 6. Okay, but then quickly show me why it is. Got it? All right, here's your assignment. You've already done the first half. So this is page 562. You guys are doing 29 to 53 odds. And they are all like this. There's nothing different, okay? All right.